Today we will solve the problem named flip string to monotone increasing. The question is, a binary string is monotone increasing if it consists of some numbers of zeros followed by some number of ones. Means in starting we can have some number of zeros, means 0 0 or 1 0 or 2 0 3 0, possibly none, or any number of many like any number of zeros. Then after zeros we should have all ones, possibly zero can also consider. So you are given a binary string s. You can flip s of I, changing it from 0 to 1 or from 1 to 0. We can change any s of I. If it is 0, we can change it to 1, or we if we don't want, we can't change, or if it is 1, we can change it to 0. So return the minimum number of flips to make s monotone increasing. We have to make string monotone increasing. So how we can do it? At any at every s of I, we have two options. We can convert it to we can convert it. If it is 0, we can convert it to 1. If it is 1, we can convert it to 0, or we can leave it to uh, that number only. Means if it is 0, we can say, okay, you you take your value as it is, and we will go forward to next s of I. So let's say we are here, I is here. So here we have two options. We can make 0 to 1, or we can say it is 0 only, we are moving to next s of I. Okay, so there is we can make the tree dp. It is a dp question, so we can make the tree. So if it is, we are at 0th position, so there are two options. We can make it to 1, or we can't. So let's say we have we haven't changed the 0, so it is 0 only. One thing we have to think, like, if here it is 1, if we have leave it to 1 only, we say we are not changing it. If we have leave it to 1, then can we change it to 0? Can we change it to 0? No. If it is 1, then all number which are after this 1 should be 1. Okay, so if I have changed this, just this position to this position to 1, if I have changed this position to 1, then all numbers, all s of I which are after this index should be 1, to make the string monotone increasing. So we have to take one variable also to know that the if from previous values we are coming, any number is 1 or 0. Like, if we are here, we have to know, we want the information that any number before this index, any s of I before this index is 1. If it is 1, then we have to make all indexes 1. There is no choice. We can't do, like, we can't say we can convert it to 1, we can convert it to 0, if its previous number is, or from where it is coming, that the number are 1, we have changed, then we have changed any s of I to 1, then we have to change all number. If it is 1, then okay. If it is 0, we have to change it to 1. We can't say it can be 0 or it can be 1. So we are at 0 index. Previously nothing, we haven't changed anything, so we say it is false. It is false. Like, we have take a variable name is 1, is 1. So initially it is 0. Okay, so now we can change it to 0, or we can't change, we can leave it to that number only, or we can change. So let's say we have changed. So now this is, we will say true. This is 1 is true. Okay, here is 1 is false. Okay. Now we are at we are at this 0. We are at this 0. Okay. If if we are at this 0, if we are coming from this, if we are coming from this side, if we are coming from this side, then we can change it to 0 or we can change it to 1, because it is not 1. It is not 1, no. So we can change it to 0. Okay, we can say you stay at as it is. So we can say, okay, you, here we are at first index, here we are at 0th index, or we can say here we are at 0th index, and here we are at first index, here we are at second index. So let's say we haven't changed, so it is 0 only. If we have changed, so it is 1. This 0 we have changed to 1, so is 1 is 1. Okay. Now from this side, if we are coming from this side, if this is 1 is true, means we have changed some number to 1. Now can at which index we are at 1, no. So can we change first index value to 1 or 0? Can we change it to, if it is 0, can we change, if it is 1, can we change it to 0, or it is 0 only, can we leave it to 0 only? No. If we have changed some number and it is, and is 1 is true, then we say there is no option, we have to, if it is 0, then we have to make it 1, and is 1 is true only. And if it is 1, then we say okay go, then we say okay go. So here we haven't changed, here we haven't changed, answer is 0 only. Here answer is 0. Here we have changed 0 to 1, answer is 1. We have to return the minimum number of flips now. So here we have flipped, here we haven't flipped. Now it is at it is at first index, first index value here we haven't changed, so answer is 0. First index value we have changed here, so answer is 1. Here first index value also we have changed, so answer is 2. Now we are at this second index at second index we have 1. At second index we have 1. If is 1 is 1, is 1 is 0 also, then also we have two options, we can change it to 0 or we can't change, we leave it to 1 only. So if we have left it to 1 only, then if it is 1, if it is 1, let's say we have leave it to 1 only. If it is 1, we have leave it to that number only, so it is 1. So then is 1 is true, because we have found 1 and we have leave it to 1 only, so is 1 is true. But we haven't changed, so answer will 0 only. Okay. If we have changed it to 0, so is 1 is false, is 1 is false, and we say the answer is 1. The answer is 1 and here answer is 0. Okay. Now if it is 1 1, at second index it is 1 only, then we don't have to change, is 1 is true, because so 1 only, is 1 is true only, and the answer is 1. Which answer is coming, we don't have to add 1, we say the answer is as previous. So is 1 is true, it is 1, we can't change, so it is 1 only, and is 1 is true, the answer is 2. Now we are at third index, we are at third index, is 1 is true, we can't change, we say you stay 1 only, and is 1 is true, and we say answer is 0. Now if it is 0, if is 1 is 0, we can change it, we can say use, if it is 1, we can say you change it to 0, and is 1 is 0, or we can say or we can say you stay that number, you just can't change, don't change, you don't change 1. So is 1 is true, is 1 is true. We say is 1 is true now. We haven't changed, but is 1 is true, no? So the answer is previous only, but is 1 is true. We have found 1 or and here answer is 2 because we have changed 1 to 0. Now if is 1 is true, it is 1 only, we can't change, so we say it is 1 only, is 1 is that only, we are not changing. Here also it is 1 and 1. Here also answer is previous value, here also answer is previous value. Now we are at last index, last index. So if it is 1, we have to change it to 1. If is 1 is true, then we have to change it to 1. Is 1 is true only. So answer is 1 because we have changed. Now if it is 1 is false, is 1 is false, and it is 1 is false, it is means it we are coming from 0, so we can change or we can't change. Let's say we are not changing, is 1 is false only, and we are not changing 0 to 1. Let's say we are changing 0 to 1 and is 1 is true. Okay, now here answer is 2, here answer is 3. If is 1 is true, it is 0, then we have to change. We have to change it to 1. Is 1 is true. If it is 1, is 1 is true, here also we have to change. Am I right? Is 1 is true, no? If it is 0, so we have to make it 1. We have to make it 1. So at every here answer is 3 because we have changed, we have flipped. So here, sorry, 1 plus 1 is 2. Here we have also flipped, here we have also flipped. So we have completed our tree. Now we have reached at last index. So now answer, what is the answer? What is answer? It is 1, 2, 3. We are coming from every call. From every call answer is coming. Answer is coming 3, 2, 2, 2, 3, 1. So what we want? We want a minimum number of flips to make it monotone string increasing. So minimum number is 1. So minimum number of flip, in one flip we can make the string monotone. Now this string is here. What string is? 0, 0, 1, 1 and 1. So it is first two indexes are 0 and other ones are 1. So it is monotone increasing and we have found the minimum answer. So it is very easy problem. The code is here. You can see it's very I have solved this by recursion memorization. So I have taken dp of s dot size plus 1 and int vector of int of size 2 for because we want the information of is 1, no, is 1 can be 1 or 0, so we have take it to size 2. Now we are saying if I is greater or equal than size, if I is here or here or here, then what is the answer? We can return 0, nothing. Now if we have dp of I and is 1 is not 1, we can say return the answer. If it have already stored the answer, we can say you just return the answer. Now if s of I is 1, then we have two conditions. If is 1 is true, then there is only one option. We have to, if it is 1 and is 1 is also 1, then we will say you just go ahead, go on the next index. Okay, if it is 1 and is 1 is not true, then we can change it to 0, or we can say you just stay 1 only. If we are saying you stay that only, then we say is 1 is 1, is 1 is true. If we are changing it, so we are adding 1, and also we are changing is 1 to false. We are changing is 1 to false because is 1 is not true. Else s of I is 0 now. If s of I is 0, then we have two options. If is 1 is true, If is1 is true, then we have one option only. Is1 is true, then we have to make it 1. We have to change. We are adding 1 and we are making is1 is true only. And second option, if is1 is false, then we can change, or we can't change. We we have two options. We can say you just stay unchanged, or we can change it. If we are we is as of I is 0, no. If we are changing it to 1, we are changing it to 1. We are saying is1 is true and we are adding 1. And if we are not changing 0, so we are saying is1 is false and we are not adding any number, 0 plus. So we have to, from both of them, we have to return minimum. If there is no option, we can say you just store the number answer. From these two also, we have to store minimum. And if it is not, if there is only one option, we are saying you just store the number only. So we are returning at last answer. We can submit the code. So it is running. Thank you.